Good afternoon. On behalf of the Duke Global Health Institute and the Center for International Studies, I want to welcome you and thank you for coming this afternoon to the University Seminar on Global Health. My name is Randy Kramer. I'm a faculty member in the Nicholas School of the Environment, and I chair DGHI's Environmental Health Working Group. Several months ago, our working group was asked to nominate a speaker for this series, and we immediately thought of Professor Kirk Smith, one of the world's leading authorities on indoor air quality, and the person most responsible for demonstrating the extremely important connections among air pollution, household fuel use, climate, and health. Just to give you a little bit of background, Professor Smith received his Master's in Public Health and his PhD in Biomedical and Environmental Health Sciences from the University of California, Berkeley. After building a world-class energy program at the East-West Center in Honolulu, he was lured back to Berkeley in 1995, where he is Professor of Global Environmental Health in the School of Public Health. He is also founder and director of a campus-wide master's program in global health and environment. His research focuses on the relationship among environmental quality, health, and resource use in developing countries, and he has ongoing field projects in India, China, Nepal, and Guatemala, and I'm sure we'll hear about some of that field work today. He has over 230 publications and serves on a number of national and international scientific advisory and editorial boards. He's received a great many honors and awards during his exceptional career. I will mention two. In 1997, he was selected to be a member of the National Academy of Sciences, one of the highest honors awarded to U.S. scientists by their peers. And last year, he received the Heinz Award in Environment for his work demonstrating the co-benefits for health and climate from improvements in household energy technologies. We're very pleased to welcome Kirk Smith to Duke University.
Well, thank you very much. It's an honor to be here. Heard about this new institute here. It's good to see Mike Burson and old colleague and new colleagues, and meet some of the exciting students you have, and people at medical school and so forth. I'm going to talk on this topic today. I do have a lot of material, and so you're going to have to shut me off at the end as appropriate. And I will give you a sort of roadmap of where I plan to go. But first, let's see, what do I need to do? I want to get us on the same page with some things related to climate. This is a graph from the Intergovernmental Panel on Climate Change, the latest assessment, the fourth assessment. And it shows the warming in the year of 2005 from all human emissions since 1750. This is just human emissions. And of course, you know, carbon dioxide, this is the measure of warming. And this carbon dioxide is the most important. But not so well recognized by many people is that there are a range of other important climate active pollutants, not all gases. And some of them are also quite important for health. And the ones I'm going to particularly talking about here are these that are products of incomplete combustion. Now, carbon dioxide, of course, is a product of complete combustion. And it is a problem in the atmosphere when you put too much of it in. But actually, every single one of these other carbon-containing products of incomplete combustion are far worse in the atmosphere than CO2. The only problem with CO2 is that there's so much of it. The other things are much worse from both a climate standpoint and, of course, from a health standpoint and actually an ecosystem standpoint. So part of the problem is complete combustion, if you will, CO2, but also part of the problem is too much incomplete combustion, both from the climate and other standpoints. So where do these products of incomplete combustion come from? Can anybody tell me the source of the products of incomplete combustion that cause the most ill health by far? Shouldn't be too mysterious sitting in this particular university. Tobacco. Yeah, I mean, this is a hint for anybody in students in health. Anytime you're asked a question about health you don't know the answer to, say tobacco and you're probably right. So the impact from tobacco smoking is sticking those in products of incomplete combustion in your mouth. That's the worst thing. But it's also bad to be exposed to in other ways. And a major source of incomplete combustion products is the source I work on, which is traditional biomass use in household fuels. And although it's not the major source of energy use worldwide, it's not a small source either. It exceeds hydro and nuclear in this particular diagram as a source of energy in the world. And of course, also you get products of incomplete combustion from poor use of coal. Black carbon, which is kind of the carbon is the climate active pollutant of the month these days. A lot of people talking about it. I understand Dr. Ramanathan is going to come next month, and you'll hear a lot more about it. This is one inventory of it. And there's a lot of it produced by forest and grassland fires, much of which is not human caused, but natural. But you'll see that households are also a significant source of black carbon. This is a product of incomplete combustion. It's black. It causes health damage, but it also absorbs sunlight, major climate acting pollutant, and also when it falls out of the air, as it does quickly, it lands on snow or ice. It accelerates the melting of snow or ice. It's not the only source. Diesel transport, poor coal combustion in industry. One of the few things that power plants don't contribute much to globally. Actually, in terms of households, 1/3 of the controllable black carbon in the world, and also carbon monoxide, another important greenhouse active pollutant, but also health damaging pollutant. 1/6 of ozone pollutants, causing pollutants, the precursors for ozone, and 1/20 of the methane emissions come from household combustion. So it's not a small actor globally in terms of climate.